Okay. Got one more sprint down the home stretch and should take care of it for the day, at least for the morning. All right, any questions thus far about what we've covered before we move on into more tree stuff?
Just to make sure I understood before, all I saw before, it only moved the head and it didn't touch any of the three trees. Like none of or like the staging area and the working direct, it didn't touch any of that. It just moved the head. Is that correct?
With the reset, the
Yeah.
Git reset hard.
Yeah.
So the hard does touch all three.
Okay. The hard puts them all in sync, and then just the default doesn't touch any of the other stuff. It just moves the head. Is that correct?
It's closer. So the default is in between. There's the we'll cover this in some detail, but there's soft, mixed, and hard. The default is mixed. So it basically if the softest only moves the head, and then mixed moves the head and the index but leaves your workspace alone, and then hard clobbers your workspace too.
Okay, so, that's right. Yeah, I remember
along the lines. Yeah. So we'll work with that some to sync that on in. For me, it did take some syncing in substantially. It definitely not intuitive, but it's just one of those things that to memorize, and then once it's memorized, then it starts to make sense. At least that's the way it came about for me. So let's work with a little bit. Any other questions? I guess first of all.
Kind of stemming off of where we left off right before the break, it kind of left me with two questions. One, is it possible, if you know exactly that a commit or that a hash isn't, if it's orphaned, in other words, nobody's referencing it, is it possible to delete that? And the second question is, would you want to delete that? For instance, if I made one commit and then reset it, recommitted or committed something different, or even if I keep the same commit, but now I have the different timestamp, I would change the hash, reset it, and I do it like 2 or 3 times, and now I'd have 2 or 3 other commits that were in there that were stored, but they're kind of orphaned.
Right. Yeah, no, that's a great question, and in fact, let me digress on that a little bit, because it's really important to, I think, understand, and it also helps you make sense of what you see in your Git graph as you maybe redo commits and get the effects that you may not expect. So, for instance, we are back at this new commit, right? That we did here. Now, suppose so I'll do the same thing I did before, but now before I leave that commit, I'm going to attach a branch to it so it doesn't disappear from my Git graph. So, by the way, that's all a branch is just a, it's a tag that you can work with. So I can say, Git branch, some name, right? Anything I want. Now I look at it. Now we see some name up there that's, I haven't committed anything, right? I've just branched. So there's no new commit. We're on the same commit, but now there's another name associated with it besides, master and head. So if I do go and do the amend, where's that amend? Let's amend again, right? Like, whoops, what did I just do? There we go. Okay, let's see what that did to our graph. So what happened here? Anybody want to take a swing at explaining what that all means there?
It looks like the red icons, sorry, to the left, the color coding, looks like the red means it was deleted or it's not referenced, and the green is where you're kind of current at for the head.
Like these bars here?
Yes.
Okay. So it changed because we changed the comment, and as we established before, that's going to hash to something different, right? If you change anything about your commit, even if the actual trees and blobs are the same in that commit, which they are, right? We can go back and we can do a git diff against those. And if we diff head with some name, same content, exactly as far as the blobs and trees are concerned. But the commit has other stuff in it, right? It has a different timestamp, has a different comment, et cetera, et cetera. So we get a divergence between these, and so that might, that threw me for a little bit, because I'm like, wait a minute, it's the same stuff. I didn't change any files. I didn't, there's the code's identical. Why am I getting a different branch here? But that just is necessarily what happens when you change a commit. Now, yeah, as Daniel, you noted this, if I hadn't put this branch here to tag it, this guy would just be gone as far as our visibility into it, right? It would still be in the database, as we saw. We could tag something to it after the fact again, but if we didn't, it would just be sitting there kind of dead. You could think of Git like, this whole graph like a big cluster of grapes, and the blobs are the grapes on the end, or even at the commit level, right? If we have a commit that the grape drops off the tree, then it can be cleaned up, and there are actually Git commands like prune that metaphorically do that. So it goes and finds all the commits that have no references and just gets rid of them, and presumably the trees and blobs too. So that it keeps your repo from just getting all kinds of cruft in it that just takes up space. And in fact, that's what, when you push your stuff up to GitHub, that's what it does. GitHub doesn't keep any of that stuff around. So if you push it up and then pull it back down clean, then it would be gone, because GitHub would have pruned it. And you can do that yourself. But on your local repo, unless you do it yourself, right, or unless you push it somewhere and pull it back clean, that stuff will stay around. And as long as it's my I guess approach to it is, as long as it's not huge, I don't worry about it. If I haven't actually accidentally committed some 10 gigabyte file to my repo, then it's kind of, it never gets in my way. Sometimes you do that, and then you have to use prune or filter branch or some real heavy duty tool to take care of your huge repo. But yeah, yeah, it's still there. It's something you can go back to, but if you go and change your history, then you're going to get these unused commits, I guess you could call them, or dead commits. But they're still there. I want to make sure I call that out. So yeah, any other questions? Does that help, Daniel?
Yeah, it does. Right now, I'm actually just trying to figure out some of the, I guess, interpreting the graph a little bit more intuitively.
Yeah.
Yeah, because I got the same kind of color code, slightly different colors, but it's the same sections are colored the same together. So. Yeah,
let's actually look at that a little bit then. I didn't go through that in detail, and I should have. So the stars are commits wherever they happen to be. You know, down, if you look a little bit further down here, this 7597 sits here. It doesn't sit here. It actually lives right there, right? It doesn't have anything to do with this this branch right here. So you have to look to see what line the stars are on in order to know where the commits actually live. And then these are just branches. They don't, their colors are only to distinguish them from each other. They don't signify any good or bad, so to speak. Like this is an interesting one here because it has two parents. So that's the definition of a merge. A merge commit is one that has more than one parent. So we can actually take that. Let's just prove that to ourselves. So Q out of here, and then git cat file -p, that guy, and sure enough, it has two parents in that commit. So that's what Git is drawing, is that two-parent relationship right here, where you merged from this commit and this commit, and then this common ancestor here where the branch happened. And then there's these different references here to where origin state, basically. That's something that you can read but not write to explicitly. You can push, and when you push and push successfully, then the origin branches will get updated depending on which ones you push to. But you can't like check out origin master and make commits to it. It's just it's a representation of what's remote. And we'll get more into remotes in the next round as we start to do some workflows in the next session. But that's what these reds are, and then here's another green. That's another local branch. Master here, you can see here that master has diverged from origin, or it's gone ahead of origin master. So I think that's another important point, as we'll get into later, to note that there's what's on the remote, and then there's a local branch that tracks the remote branch. So you can't only work with origin master. You have to have your own local master pointer here to work with, and then update by pulling or push your updates by pushing. And then this little arrow that denotes that symbolic reference that we talked about, where head is not an actual SHA, it's only a symbolic reference to something that is an actual SHA. Let's see, anything else interesting here? Yeah, that's pretty much it. Yeah, there's a branching operation here that happened, and a merging operation here that happens. You can add some more formatting to the log command, and you can see things like the date and the user that did each commit. But what you see here is pretty much the essence of the Git graph. So, any other questions about the Git graph? Okay. I'm going to, so if you haven't used Command K, that's a very handy command. It just, in Mac OS, it clears the screen. So and also clears your history too. So you could just kind of unclutter your terminal window and move on. Okay. So here we are, moving a change forward through the trees. Let's work through some of this stuff here. Which branch we're on, okay. Go in here, feel free to walk through this with me on your own environment. Okay, this is a file. So I'm just gonna echo that stuff. And then clobber it by using a single redirect instead of a double redirect. Double means put append onto the end. Single means clobber it wholesale. So there's that. Okay, so now we see this. You may have noticed the Git status gives you status about your various trees, right? With reference to head. So there's nothing staged. So that what that means is nothing staged actually means, it doesn't mean there's nothing in staging. It means your staged looks exactly like the rest of your, it looks exactly like head. They're in sync. So it's a little nuanced, but I think it's significant. So there is a staging area. It's just in sync right now with head. But our workspace has been changed, right? So we git add, we can say the specific file, or we can just say git add space dot, and that takes everything that's different, including your untracked stuff. So something to be careful with if you have stuff that you don't want to be tracked, but it's also very handy. So now it's moved and changed from red to green, which tells us that, before it was not staged, now it is staged. Changes to be committed, and we have to unstage it if we don't want it to be there anymore in that index. Now we can, at this point, we can do differences between our trees with Git. So if we do just git diff, what does that tell us?
That right now our current tree is still matching our, I guess, Git, the original origin master.
Okay. It's our current tree in the sense of our workspace. Our workspace tree. Yeah, it's by default it compares your workspace tree to the index. And we don't really have any differences because we took, with our git add, we took what was in our workspace tree and we copied it to the index. So now they're in sync. So git diff returns no difference. What if we do this though? What does that tell us?
It shows us the modifications that were specifically done between what's staged and what was in the original index.
Yeah, and what was in the original index was what was in head, right? Because we started out with no differences anywhere. So we moved our change from workspace to index. So git diff tells us workspace versus index. Git diff stage tells us index versus head. And that does have a difference, right? Because we haven't committed it yet. Once we commit it, then it'll go on over to head. But yeah, so we are, if we look at this graphic here, this is what we did. We moved our files from working directory to index. And so I made an alias for git diff dash staged, because that's handy to tell me where I'm at. If I'm working with a lot of files and I'm just populating the staging, it just tells me what I've got where, what changes are where. And then when I'm ready to commit, I can do a final, GDS, and that tells me the whole sum of, okay, what am I about to put in to Git here? And then, make sure I check through that everything is like I expect it to be. And then, commit it after that. It looks good. But those for me come in very handy. The, GD for Git diff and then GDS for Git diff staged, just to know what the status of my trees are with respect to changes. So, okay, so let's commit it then. Oops. C dash m quote. Okay. So what will Git status tell me now?
It should say that you're one commit ahead of masters since we haven't pushed it, but other than that, it should say it's good.
Yeah, although with my garbage commit, it says I'm ahead by 2, but yes. So, so yeah, I've got it in, and now my changes moved all the way from workspace to index to now where head has, of course, moved to since I've committed. So now they're all back in sync. So all 3 of my trees are lined up again as far as changes are concerned. So let's say I didn't want to do that. I changed my mind, right? Let's head now. Okay, just kind of get our bearings here. The parent of head is this guy. So let's say I forgot a file. I have 50 files and I committed them, and I just, there's one that I didn't get into the index. It's all the same sort of change set, but I want to add that file. So wouldn't it be cool if I could just uncommit but leave everything staged, because maybe I've got other stuff that I didn't want to actually commit, so it's in the unstaged section. So I just want to take that stage stuff and bring that file on in and join it. So let's actually maybe say I wanted another file in there, right? I made a change here. Sorry, I'm dropping into Vim for a minute. My bad. Okay, now I'm back out. But wait, what? Let's do. Okay, yeah. So now, I got it modified. I wish that would have gone in there too. So I can do a Git Reset soft, and remember, I have to tell Git Reset where I want to go back to, and where I want to go back to is the previous commit, at least for some of my trees, not all of them. So what I'm saying is I only want my head to go back. I don't want my index and my workspace to change. I'm going to just pull the head back and leave everything in the index that's still there. Because remember, if head and index are lined up, it doesn't mean there's nothing in the index. It just means that they're in sync. They have the exact same content on them. So now I'm going to pull the index back and leave that content kind of exposed like it was before, with respect to being changed. So now if I say status, okay. So now I can use my git diff staged to verify. And it just shows that a file because that's what's different. That's what's different with respect to head now, because I moved head back. So nothing has changed in index. Nothing has changed in my workspace. at least not with this Git reset. The only thing that's changed is I pulled head back by one commit to the parent, right? Pulled it back to the parent of the commit that I was on. So now I've got something staged. Now I've got this file I've got modified. So now I can move that file into the index with git add. And now I can join the one I had there before. Right, so there they are. Now they're both happy. Now I've got the kind of commit that I want. I can go back and find my up arrow to my other command and run it again. And now it's got 2 files changed instead of 1. So this is kind of a contrived example with only 2 files, but if I had, you know, a whole bunch that I was working with of files and directories, it would be a lot more meaningful to be able to, you know, leave that index like it was, except for just putting one more file in there, and then redo the whole thing. Right, and so anything else I want to talk about there? So this is an example of the soft, pulling the soft one, just changing one tree. Suppose I wanted to go and, you know, change a lot more, right? I just, maybe this commit wasn't ready at all. I just, you know, lost track of where I was, or maybe I forgot to run my unit tests. And when I finally got around to running them, they failed miserably. I'm like, this is not ready. So you can go a little further, right? And as I mentioned before with Daniel's question, you could say git reset head, which is really the default value. It's the same as saying this, -- mixed. So I don't know what mixed means exactly, but it does mean that you change 2 trees instead of 1. You change head and you also change the index. You pull them both back to the parent of head here that we're pointing to. But you still leave the workspace alone, right? So 2 of them change, workspace stays the same. So what do I get now if I type git status?
I should see some files that are either untracked or not, that are ready to be staged but aren't staged yet.
Okay. Will I see any untracked files?
No.
Correct. Because I didn't have any before, you know, when I ran the git status before I did the reset. Okay, so exactly, like you say, they're not staged for commit. So that means that I've changed head and I've changed the index to match head, you know, what head has become, but I haven't changed my workspace. So the workspace now shows, you know, in a relative sense, those changes. So now I can basically kind of pull everything back and put it back on the workbench and, you know, do what I need to do. And then, you know, try the commit again. And of course, it's going to be a different SHA because of all the reasons we discussed before, just different content. So that's, you know, that's going the other way, right? Here's the green path, and now we can pull back into specific places in the reverse direction based on what we want to do with that, you know, with that set of changes. So if you were going to implement the -- amend, remember that the one that we used to change the comment, what set of operations might that correspond to in terms of what we've looked at?
Would it be just a soft reset?
Yeah, yeah. There's no need to go all the way back to your workspace for just changing a comment, right? So yeah, I could just do a git reset -- soft, and then the parent of head, and then a git commit with another comment, and I've done basically the exact equivalent of -- amend. I'm going to Control C out of that, not run that. But so there's more than one way to do it, and it kind of gets back to, if you know the basic kind of layout and data model of Git, you can choose from this gigantic constellation of complex commands, and find one that does, or maybe several that do what you want done. But if you have a good firm picture in mind of what the graph ought to look like, and what kind of where things are in the Git database, and how to connect them together, with some of these basic commands, then you can eventually make it look like you want it. And if you take the long way around, that's fine, as long as you know where you're at in the space. And that's the idea of this, these trees and objects here, is if you know which tree you're on and what objects you're working with, and how to get back to them if you get off track, then you can get your way to where you want to be, and probably help others as well. Okay, what time is it? We're about 11:30. I think that's about all I've got here. Let me review and make sure that we've covered the things I said I was going to. Talked about Git revisions a little bit. There's a reference in Git SCM if you're curious about that more. We talked about the commit, and it's still being there, even though we moved away from it. Okay. Okay, one more nuance here. What if we did just a Git reset right now? So let's see where we're at first. We're Git status. Let me put that back in. Actually, that's not going to work. I have to do Git add first, right? Okay, so Git status is empty. Everything's in sync. What if I did a Git reset right now? What would happen? This. So what happened? Nothing, right? I mean, head is the same as it was. Here's where our head moved to. Here's what our head is now. Just to point out that if Git reset by default goes to mixed, if you don't tell it which one for hardness, and if you don't tell it which place to go, it just goes to head. So you can use that though to your advantage, suppose I change a file. Right now, I do git diff. So I've got a change in there, right? That maybe I don't want. So if I do a git reset, okay, that's already what I had before. But if I want to recover everything that and just make my workspace like head now, just basically throw away my changes, what would I say there?
It would have to be hard.
Yeah, exactly. Because hard changes, makes everything like the thing that, it makes everything like the SHA that I pointed to. And this, if I don't tell what SHA, it's going to be head. So what I'm saying is make everything like head. And now my change is gone, right? Because now everything is like head. So I'm not always going to point to the thing before head. Sometimes I'm going to point to head to accomplish what I want as far as resetting just my workspace. So I can use git reset for that as well. Okay. I think that does it for this particular section here. I did add one more sort of picture just to kind of illustrate what's going on. So here, you know, if you do soft, only head is changed. If you do mixed, head and index are changed. And if you do hard, all three of workspace, index, and head are changed. So that's, you know, that's another way of thinking about it. So the two takeaways for Git Reset is you have to tell it how hard you want the change to be and where you want to reference to. What do you want to change it to? So I guess to finish off today, it may come in handy to be able to distinguish between Git and GitHub, because everything now with Git seems to revolve around GitHub, but it doesn't have to. So this table at the bottom basically identifies a few commands that help you know if you're working with Git or with GitHub. In my sessions, we're only working with Git. We're not doing all the social coding aspect that GitHub is all about. So for instance, if you see something about fork or pull request, pull is Git, pull request is GitHub. That's, you know, you comment on pull requests and review them and, you know, accept them and all that. But a pull is simply just grabbing SHAs from your remote and copying them over and making them part of your world as well. We'll talk more about that next time we go into more Git workflows. A repo, there's repos. They're pretty much the same in both the Git and GitHub worlds, except that your GitHub repo has all kinds of metadata around it, right? It has like, you can have a wiki, you can have issues and be part of a project and permissions and all kinds of stuff like that that are not part of a Git repo. And organization, that's another GitHub concept, as well as, you know, org owners, teams, collaborators. Those are all GitHub. But Git is just clone, merge, commit, push, pull. That's when we're talking about Git. So for what that's worth, if you have any questions about that, or, you know, wonder which, you know, there's lots of other terminology out there that sometimes is worth distinguishing between as well. Okay, so we have covered pretty much everything that I think we were going to cover today. I'm looking down